Hello everyone, this is Amira. In this video, we are going to build a machine learning system. Okay, so we will be using one of the important machine learning algorithms, support vector machine. First of all, let's try to understand about this support vector machine algorithm. So this is one of the important algorithms of supervised learning algorithm. So in supervised learning, we feed the data to our machine learning model, and the machine learning model learns from the data and its respective labels. So here the labels are the most important things. So what happens in this case? We train our model with several medical information such as blood glucose level and the insulin level of the patient, along with whether the person has diabetes or not. So this acts as labels whether the person is diabetic or non-diabetic. So this will be the label for this case. So once we feed this data to our support vector machine model, what happens is it tries to plot the data in a graph, and once it plots the data, it tries to find a hyperplane. So in this image you can see the hyperplane. So what happens is that this hyperplane separates these two data. So once we feed a new data to this model, it tries to put that particular data in either of these two groups, and by that it can predict whether the person has diabetic or not. So in this case we use several medical information such as BMI of the patient and their blood glucose level and their insulin level and etc. So now let's try to understand the workflow for this project. So first of all, we need this diabetes data. You can download it from the link of the GitHub repository that I will give you. We'll try to train our model with that data and the respective labels. So before feeding this to our model, there are a lot of steps in between. So the next step, we need to pre-processing the data, where we will try to analyze the data. This data wouldn't be very suitable to feed to the machine learning model, and we need to standardize this data because there are a lot of attributes here and a lot of medical information, and we want all this data to be in the same bridge. So what we do is we try to standardize all this data so that all this data lies in the same range. So all these things will be done in the data processing. So once we process the data, we will split the data into training and testing. So we will training our machine learning model with training data, and then we will try to find the accuracy score of our model in the help of test data. It is well our model is performing. So once we split the data into training data and testing data, so we will feed this to our support vector machine model. So we will be using a classifier model. This model will classify whether the patient is diabetic or not. So once we have trained it, we have a trained support vector machine classifier. So when we give a new data, it can now predict whether the patient is a diabetic or not. So this is the workflow we will be following for this project. You can download the coding file and the data from this repository. So now let's get into the coding part. First of all, we will import all the libraries that we will need during this project. Import numpy as NP. This library is useful for matrices. Import pandas as PD. This library is useful for creating data frame. We will use this library to load our data. From sklearn.preprocessing, import standard scalar. This standard scalar is used to standardize the data to a common range. After that, from sklearn.model selection, import train test split. We will use train test split for splitting our data into testing and training. And from sklearn, import SVM. SVM is a support vector machine algorithm in machine learning algorithm, and this is a supervised machine learning algorithm. Support vector machine is using for classification or regression. If you use support vector machine as a classification, just write SVC. If you use support vector machine as regression, write in the code SVR. And from sklearn.matrix, import accuracy score to get the accuracy of our model. So to run this, just write shift and enter. Now we will do our data collection part. You can download this data from this website. To load your data, just write pandas.read.csv and the name of your data, diabetic.csv file, and to store the data that you have read here, store it in a variable diabetes dataset in the variable diabetes dataset. If you want to see what our data is about, just write the name of your data that you have stored in this variable .head. It will give you the first 5 rows in the data. This dataset includes the data for all the female. So you can see here the number of pregnancies, glucose level, blood pressure, skin size, and insulin, BMI data. BMI stands for body mass index, which is basically calculated by dividing the weight by 8 square. And then we have diabetes per degree function, which is basically a number which indicates some diabetic value. Then we have age, then we have outcome. 1 represents that the person is diabetic, 0 represents that the person is non-diabetic. If you want to know how many column and how many row in our dataset, just write your name of your data frame .shape. It will give you 568 row and 9 columns. If you want to get more information about the data, a statistical measure of the data, just write the name of your data and describe. It will give you the count and mean, standard deviation, and minimum and max. The aim from our project is to make a predictive system that from this data will predict that a person will be diabetic or non-diabetic. At the end of this video, we will get any data from this data, for example this column, and we will not get this outcome, and we will test this row and wait for the model answer to tell us if the person is a diabetic or non-diabetic. If you want want to know in this out how many persons are diabetic and how many persons are non-diabetic, just write the name of your data set and the name of your column outcome dot value count. It will give you 0. The number of 0 is 500 and the number of 1 is 268. So that we have non-diabetic persons 500 and have diabetic person 268. Non-diabetic represents 0 and diabetic represents 1. If you want to get the mean value for persons who diabetic and non-diabetic, just write the name of your data frame dot groupie, the name of your column outcome dot mean. It will give you the means for two values 0 and 1, all the means for persons who are diabetic, for persons who are not diabetic, and persons who are diabetic. It will give you the mean value of pregnancy, glucose, blood pressure, skin sickness, insulin, and BMI, and the rest of your column. So this difference is very important to us because this is what machine learning algorithm will see and detect, that if a person has this kind of values, for example, if a person has a value in the range of 13, so this person will not be diabetic. Another example, if the blood pressure is in the range of 70, this person will be diabetic. So these are some important insights we can get from this data. If you want to separate the data and labels, we want to remove this column outcome and store it in a variable and store another column in another variable. So that is what we have done here. Diabetic data set, the name of your data frame dot drop columns equal outcome axis equal 1. This line means that you have deleted the column outcome from your data and store it in a variable x. The next line y equal diabetes data set dot outcome, that means you have to store the column outcome in the variable y. If you want to see the values of x, just write print x. It will give you all the column except the outcome. If you want to see y, it will give you the value of the outcome. Axis equal 1, that's because you have dropped a column. If you want to drop a row, just write axis equal 0. After that, now we are going to do is standardize our data. This is one of the important steps in data processing. Just write the standard scalar function and store it in the variable scalar. Now we want to fit this data in this scalar. Just write scalar.fit and pass your x variable. X variable that you have stored your data except the outcome. Now we need to standardize the data. Just write scalar.transform x and store that in the variable standard data. So basically what we are doing is fitting all these inconsistent data with our standard scalar function, and based on that standardization, we are transforming all the data to a common range. So this will give the data in the same range. If we print this standardized data, we got this array. As you can see here, all these values for the range of 0 and 1. This will help our model to make better prediction because all the values are almost in the same range. We will give this standard data that we have created to a variable x and the column outcome to a variable y again. If we print the variable x, we will get the array that we get before, and if we print the value of y, we will get the column outcome. We will use this x and y for training our machine learning model. So basically x represents the data and y represents the model. Now we will split our data into training data and test. To split that, we will write x train, x test, y train, y test, and write the function train test split. It takes 5 parameters x, and this is your data, y is your model. Test size that you 0.2, that means you will split your data into 20% for testing and the other for training. Then we will stratify based on y. So basically y is the values 1 or 0. If we don't try this stratify equal y, maybe all the cases for diabetic will go to one data frame and maybe non-diabetic cases may go to x. So that is the reason we are using stratify y equal y. And then we have random state. We set random state equal to 2. Let's say for example you are making this similar code and you want to split the data in the same way I did. So in that case you need to mention the number 2. So if I mention the number 1, the splitting of data will be different. So if you want to replicate that split, you can represent 1. So now we will see the shape of our data, x train and x test. X is our original data. X dot shape will give you 768 row and 8 column, and for x train dot shape will give you 613 row and 8 column, and for x test dot shape will give you 154 row and 8 column. Now we are going to train our model. We will training our model using SVM because we are using SVM support vector machine here as a classifier. We will write .svc. SVC stands for support vector classifier, and we will choose the kernel equal to linear. Support vector machine has other kernels, like each kernel has its pros and cons. This will load the SVM model to a variable classifier. Then we will training our data by using this classifier. Just write classifier.fit x train and y train. This is the data that we want to train. Basically what we are doing here, we are fitting our data with this classifier. Now we will evaluate our model. So first let's try to find the accuracy score on our training data. But before that, we should predict our x train data. To predict our x train data, just write classifier to predict x train data And if you want to find the accuracy score, just take X-train prediction, the variable that you have stored classifier to predict X-train here, and the second parameter will be Y-train data. So we'll try to predict all this training data. So we will compare the prediction for our model to the original label. So we're comparing the X-train prediction with the original label Y-train. Run this and you will get the score is 0.7866, and this is good score. We will do the same thing for our testing data. Just write X-test prediction to store our predicting X-test. Just write classifier to predict our X-test data, and we will store it in X-test prediction, and we will apply the function accuracy score to our X-test prediction with our original data Y-test. This is the important step because the model has already seen the training data, because basically we are training the model with the training data, and it doesn't make sense if we only evaluate our model based on that training data. So we need to use the model to predict some unknown data. That's why we make accuracy score to our testing data. This data he hasn't seen before. It tells us how our model is performing. Now we will making a predictive system. We will give our model just this column, the value of this column, and we will not give him the outcome. He will predict the outcome. The result he should tell us if the person he is diabetic, if the person he is diabetic or not. We will open our data with Notepad. Just write open with and choose Notepad. For example, I will get this data except the 0 and copy this and paste it here and store them in a variable input data. We will convert this input data to a numpy array. Just write numpy.as array and input data as a parameter. After that, we will reshape our data. So what is the reason for this reshaping? That's because our model is trained on 768 examples, and there are totally 8 columns in our model, but in this case we are just using one data point. We don't have 768 rows. So if we don't reshape the array, what the model expects? It expects 768 rows, and you are giving him just one row. So this will make confusion to our model, and hence we need to reshape the array. And this reshape will tell the model that we are just going to need the prediction for only one data. So that is the reason for reshaping. After that, we will do the same thing that we have done before. We need to standardize our data. First of all, we need to apply scalar.transform input data to reshaped, that we have reshaped data here, and we will store it in a variable standardized data. Then we will make predictions. Just write the classifier.predict our standardized data and return the prediction. If the prediction equal to 0, that means the person is not diabetic. That means the person is not diabetic. And if the prediction is 1, that means the person is diabetic. And if we see the result is 0, that means the